Hello students, in this lecture we will learn Fourier series, and in that lecture we have to find out the Fourier series of the given function. Now in that the given one function and we have to find out Fourier series, but the function satisfies the some condition, and that the first condition is a periodic function. If the function is a periodic function, then we can find out the Fourier series of the function. So what is meant by periodic function? Now here is the definition. A periodic function is a function that repeats its value on regular intervals or periods. For example, the most famous periodic functions are trigonometric functions: sine, cosine, tangent, cotangent, secant and cosecant, etc. Other example of periodic function in nature include light waves, sound waves and the phase of the moon. And mathematically, if we have to check the given function, it is a periodic function, then in that case we use the definition. A function f of t is a periodic function if the function values repeat at a regular interval of the independent variable t. The regular interval is referred to as the period if t, capital T, denotes the period we have. Suppose I am replacing in the given function t plus t, and after solving this f of t plus t, if you got again f of t for any value of t, then we can say that the given function is a periodic function. For example, sine t plus 2 pi. As we know the formula of sine a plus b. So what is the formula of sine of a plus b? It is sine a into cos b plus cos a into sine b, right? Now here a is t and b is 2 pi. Now substitute the value in that formula. So this is sine t into cos 2 pi plus cos 2 pi into sine t. As we know that sine 2 pi is 0 and cos 2 pi is a 1, then it gives the value sine t. Similarly for cos of t plus 2 pi, if you solve cos of a plus b using the same formula cos of a plus b, then you got cos t. It means after 2 pi it generates the same value. So the period of this function, it is 2 pi. And there are again some condition for the given function. If it satisfies the Dirichlet condition, then we can find out the Fourier series of that function, right? Now the definition of Fourier series. Now Fourier series. So the Fourier series of the function f of x is given by f of x is equal to a naught by 2 plus summation n is equal to 1 to infinity an cos n pi x upon L plus bn sin n pi x upon L, where the coefficients a naught, an and bn are called Fourier coefficients, and in that we have to find out the values of a naught, an and bn using this integration. Now this is also called as trigonometric series because it contains cos and sine. That's why it is also called as trigonometric series. If you run this summation, then you got the series in the form of cos and sine. So it is also called as trigonometric series. Now where in that we have to find out a naught, an and bn. So the formula for a naught, it is, now this definition I am writing here, it is general definition in the interval c to c plus 2l, right? So remember this. So a naught is equal to 1 upon L. Integration is going from c to c plus 2l f of x dx, an 1 upon L c to c plus 2l f of x cos n pi x upon L dx. bn is equal to 1 upon L c to c plus 2l f of x sin n pi x dx upon L, right? Now suppose we have to find out the Fourier series of the given function in the interval 0 to 2 pi. Now in the previous slide we see this series, it is defined in the interval c to c plus 2 pi. In particular case, suppose they given the interval 0 to 2 pi, then for that we have to find out the formulas for a0, an and bn. Now here interval is 0 to 2 pi. So compare with the general definition of the Fourier series, which is defined in the interval c to c plus 2l. So c less than x less than c plus 2l. If you compare with this, so the value of c is 0 and c plus 2l is equal to 0 plus 2 pi. So this is 2l is equal to 2 pi. Right? Now, so after solving this term, so you got l is equal to pi. So therefore, in the general definition, there is a cos n pi x upon n and sin n pi x upon n. So in that, cos n pi x upon n is equal to, now the value of L is pi, so substitute that value is here. So L, it is pi, so n pi x upon pi, so pi get cancelled, so this is cos nx. Now instead of cos n pi x upon L, we write here cos nx. Now remember this, it is in the interval 0 to 2 pi. Now in the interval 0 to 2 pi, we write cos n pi x upon L, it is nothing but cos nx. Similarly, sin n pi x upon L, this can be written as cos nx. Now, the limit of the integrations are changed. So, c to c plus 2l becomes 0 to 2 pi. Now, for that interval, we write the Now, we rewrite the definition of Fourier series in the interval 0 to 2 pi. Then the Fourier series of the function f of x is given by f of x is equal to a naught by 2 plus summation n is equal to 1 to infinity an cos nx plus bn sin nx. Now student, remember this is Fourier series in the interval 0 to 2 pi, right? Now next, so the formula in the interval 0 to 2 pi, it is a naught is equal to 1 upon pi 0 to 2 pi f of x dx. So an is equal to 1 upon pi 0 to 2 pi f of x cos nx dx. So again bn 1 upon pi 0 to 2 pi f of x sin nx dx. Now this is the Fourier series in the interval 0 to 2 pi, right? So now take one example. Now I am making a type. So here first type, it is the function which is defined in the interval 0 to 2 pi. So find the Fourier series of f of x is equal to x in the interval 0 to 2 pi. Now in this unit, the given function is always a periodic function and always it satisfies the Dirichlet condition. So don't think about the periodicity of that function, right? So always the given function is a periodic function. Now here f of x is equal to x in the interval 0 to 2 pi. Now here they want the Fourier series in the interval 0 to 2 pi. So the formula for that Fourier series, it is f of x is equal to a naught by 2 plus summation n is equal to 1 to infinity an cos nx plus bn sin nx. Now here we have to find out the Fourier series for the function f of x in the interval 0 to 2 pi. Now, calculate the value of a naught, an and bn. Using this formula, it gives the value of a naught. So, a naught is equal to 1 upon pi. Integration is going from 0 to 2 pi f of x dx. Right? Now, f of x, now here they given the function, it is f of x is equal to x. Now, substitute that value, or you can put this value in the above formula. Then a naught is equal to 1 upon pi integration 0 to 2 pi x dx. Now here we have to solve this integration x dx. Now it is very simple integration. So how to solve this integration? We know that the general formula of the integration x raised to n, integration of x raised to n dx, it is nothing but x raised to n plus 1 upon n plus 1. So using that result, the integration of x dx, it is x square upon 2. Now bracket complete, put the limit 0 to 2 pi. Now here we have to put upper limit and lower limit. As we know how to solve this integration, or how to put the values of upper limit and lower limit. In that, we put first upper limit, then subtract lower limit. So the value of upper limit, it is 2 pi. So substitute here. So it is 2 pi square upon 2 minus lower limit 0 square upon 2. After solving this, you got a naught is equal to 2 upon pi. Okay. Now this is the value of a naught. Now next, find out the value of an. So the formula of an, it is 1 upon pi integration 0 to 2 pi f of x cos nx dx. So an is equal to 1 upon pi integration 0 to 2 pi x cos nx. Now it is x into cos nx. So here we have to use UV rule, right? So by applying the UV rule, then an 1 upon pi. So the integrate, then this is x is u and v is cos nx. So the integration of cos nx with respect to x, so it is sin nx upon n minus the derivative of u. So the derivative of x with respect to x, it is 1. Now again take the integration of this term with respect to x. So this is minus cos nx upon n into n. So it is n square. Now this is the integration of x cos nx. Now put the upper limit and lower limit. So next, so an is equal to 1 upon pi. So put upper limit 2 pi sin 2n pi n plus 1 cos 2n pi n square. So this is the value of upper limit and this is the value of lower limit. So 0 into sin 2n 0 upon n plus 1 into cos 2n 0 upon n square. So as we know that cos 0 is 1, sin 0 is 0, cos 2n pi is 1 and sin 2n pi is 0. So use that value in above equation. So it gives an is equal to 0. Now next we have to find out bn. So bn is equal to 1 upon pi integration 0 to 2 pi f of x sin nx dx. So now again substitute the value of the function. So the value of function is x sin nx. Again apply the UV rule. Then you got bn is equal to 1 upon pi x minus cos nx upon n minus, so the integration of this term, it is again minus sin nx upon n square. So put upper limit and lower limit. After solving this, you got the value of bn is equal to minus 2 upon n. Now substitute all this value in a Fourier series. So f of x is x. So the value of f of x is x is equal to, now a naught is 2 upon pi. So it is, so 2 upon pi. So 2 get cancelled. So you got 1 upon pi. Now an, it is 0. So 0 into cos nx plus bn, it is minus 2 upon n sin nx. Now after solving this, so you got the Fourier series x is equal to 1 upon pi plus summation n is equal to 1 to infinity minus 2 upon nx sin nx. Okay, now this is the Fourier series. In the interval, it is the Fourier series of the given function f of x in the interval 0 to 2 pi. Now here always remember this thing, the interval is very important, right? In the next lecture we will see the problems based on the interval minus pi to pi. So thank you.